That's pretty good. I don't think it's an audio. They got you an audio engineer.
Well, I'll say, Johnny. My name's Johnny.
Hello.
Hello.
How are you all doing?
Good.
Most of you know me. I'm Ernest Burguieres. I'm the councilman for District 3 of the Old Town. This is Rick Danielson, councilman at large. I call this neighborhood meeting because, like many of you, as the longer I live here, we get problems with this flooding that comes from the lake, and it drives us crazy, and it costs us a lot of money. We all enjoy this little bit of paradise, and we'd like to find a way to make it better and not have it, further away. When I first came here about 20 years ago, I didn't realize that there was such a flooding issue because all the older folks who lived here much longer than I had said, well, it's never flooded like that before. And so I started talking to a lot of people. And I met Ren Clark. I think Nancy's here, I don't know if Ren's here or not. And Ren and I started talking about flooding issues. And he made an interesting comment. He said, the seawall was rebuilt in 1993. And it was designed when the drainage pipes from the north-south roads like Girard and Wilkinson and stuff go through, they go through the seawall and empty into the lake. They were designed to have one-way valves so that when the lake rose, the water wouldn't come up the drains. Well, I got a copy of the engineering plans when the Corps of Engineers and DOTD did this thing. And in fact, they have been designed for these one-way valves. That was 20 years ago, 1993. They were never put on. And I kept on asking people why they weren't put on. It said, oh, they won't work, they're going to silt up, they're going to this, that, and the other. And it seems silly to me. And if you look, you're going to see tonight, two people are going to come speak. One is Michael Gurtler, who is a resident of Old Mandeville. He's an engineer. And he's prepared a visual aid for you from information we got from prior city engineers. And Glenn Mesman with HMI Inc. He's a company up on 59 and was it 1088?
Yep, right at 1088, 59.
They sell one-way valves. So, I know it's a long way to go to get them, but this is not to advocate for anything, but I'm affected by it just like you all are, and I don't see why we can't resolve this thing. I mean, it was studied 20 years ago. How many times do you have to study it to fix it? What you're going to see tonight is an explanation of what happens, and when you see visually what happens, it's going to make perfect sense. Because a lot of times, I think Jared Burrow, I don't know if he's here yet or not, he lives on Lakeshore Drive. He emailed me this morning, or this afternoon, and says, water's coming up the drains and stuff, and we don't have a hurricane. And this is just a slight southerly wind. It's a constant problem because the water is coming in through these drains. And so we need to find a way to stop it. That's not going to solve all of our flooding problems. It might not solve half of them. It'll solve some of the problems. And I'm going to show you also a fascinating video of a company in England that makes temporary flood structures. Now, you all may have heard of different solutions to this flooding problem. The big solution would be if we had floodgates at the Burguieres, at the mouth of Lake Pontchartrain. That was thought of 40 years ago. And a group called Save Our Wetlands stopped it because they said it would hurt the environment. But I think everyone realizes that if you were able to cut the water out from the Gulf of Mexico at the Burguieres, it would not cause the lake to rise so much and flood everybody out. The long-term solution would be to do that, but I don't think it's going to happen in our lifetime. The state of Mississippi is very much opposed to it because they feel if the water stops at the Burguieres, it'll come over to Waveland and Bay St. Louis, and it might, I don't know. And so the federal government's not going to spend money there. The state is not going to spend any money to save Mandeville. We already know that the parish, the flood money that they get for elevation, they're spending it in Lacombe. They're not spending it in Mandeville. And so Rick and I started thinking, we might have to try to help ourselves to the extent we can with the resources that we have. We don't have $100 million or $1 billion to spend. We've got some money to spend. And a question of priorities, so where are you going to devote those priorities? Do you want to put bathrooms on the lakefront, or do you want to try to stop the flooding from coming in? Do you want to repave Girard Street, or do you want to try to stop some of the flooding? The flooding costs a tremendous amount of money to everybody who lives within 1,000 feet of Lakeshore Drive. And it happens not every year, it happens every few months as a southerly wind. It's not just a hurricane event. Hurricane Katrina was an anomaly that had, was, in my lifetime, was equivalent maybe to Betsy. And that's just a worst case scenario. And I don't know if anybody can ever solve that problem. But if we can solve all the ones in between or reduce the effect, I think it will improve the quality of life for everybody here. And that's where my focus is. And I don't mind getting on, up there and start rolling up my sleeves and finding out a solution. I'm going to turn this over to Mike Gurtler now, and he'll explain to you what's happening with these street drains in Mandeville. Mike?
Thank you, sir.
Thank you.
own an engineering company. I don't do water engineering or hydraulic engineering. I have no vested interest in this other than as your neighbor to try to explain to you what happens in Mandeville and why we get so much water in the streets on such a regular basis. This is a drawing that actually comes from Mr. Ernest's Corps of Engineer documents. What they did when they built the seawall in the mid-90s is they surveyed the streets and they surveyed all the drainage systems going back several blocks into the neighborhoods. And they drew contours of the streets. Bear in mind that the lakeshore, the lakefront moves up and down as it goes, and the streets undulate as they go up and down. Wilkerson Drive happens to be the one we picked. If we use Carroll, the street I live on, Carroll's actually much flatter in this front section. My house is at 129. After it passes 129, it kind of goes up precipitously to where the Scott's Coffee Shop is, and then it goes back down toward Wren's house because there's a little bayou that kind of snakes in and works its way over to where the Catholic Church is and then works its way back toward the May Street plantation on Monroe Street. What the Corps did is the old seawall was shown in really jagged lines. It must have been in deplorable condition. I don't know. I never saw it. I moved here 13 years ago. The new seawall, this is 0, which is basically supposed to be mean sea level. Water level in that lake is usually a little bit higher because water is draining through the lake going out to the ocean. So they actually peg the water level at almost +1. The top of the new seawall is here at elevation about 4.5. The drain system actually is below the bottom inlets of the drain. The bottom parts of the drain pipes actually below sea level. There's always water in the bottom drains at Lakeshore Drive. This relatively large concrete pipe goes to the other end of Lakeshore Drive and then actually feeds both sides of each street feed into one pipe to go out, as I understand it. Then the pipes begin to change dimensions. These are actually catch basins that are conducting water from the middle of the street down into the drain system, and the drain system has a very small slope from this point here, which is Jefferson Street, which is roughly 1,500 feet back. The amount of elevation difference is only about 4 feet. Again, I don't do drainage. In engineering school, I remember them teaching us that in order to get water to drain through a pipe, it has to have 2 components, the size of the pipe and the slope. A fast sloping pipe drains a lot more water, an almost flat pipe drains very little water. There just isn't a whole lot of contour here to drain a lot of water. What happens to us is when water starts coming in the lake because of a storm, let's just say water gets up to the 3-foot mark. Water actually goes backwards through these pipes, floods Lakeshore Drive, and begins to flood in some places the land between Lakeshore Drive and the seawall, and in some places starts working, like Carroll Street starts working its way up Carroll Street. I know it's flooding because I have an open ditch across the street and I can watch water rise out the ditch, crest over Carroll Street, and come toward my property. As water comes up, and I've seen this, I've actually lived at water at 4.5 feet out in the lake. And that's not water coming over the seawall. A little bit of water every time rain comes is coming over the seawall. What's happening to us is water is coming through this drain system and coming out. And sometimes it comes out all the way over at Jefferson, sometimes it comes out a block farther up from Jefferson. And by Wren's house, the water is actually coming out of the drain system and inundating that little bayou. And there are 2 openings in the seawall which also contribute to this. One is over here by the Yacht Club, and the other one's between Carroll and Coffee Street.
Little bayous.
Little bayous. And those allow free flow of water from the lake inland, and once it gets in there, it begins to spread and covers ground, cutting literally the end of Carroll Street. I'm high and dry because I'm 18 feet above sea level, but I can't drive out, not because Carroll Street's flooded, but because the next block in is flooded. So the water is actually, it's all based on gravity, and the higher the water level gets in the lake, the more water ends up over here, but my point is, it's still below the seawall, and none of that should be happening. As Mr. Ernest pointed out, this is the actual diagram of what the ends of the pipes look like, and the Corps of Engineers put flanges on them with holes in them, intended for a flapper valve to be put on them. They just never installed them. Those flanges are still sitting there. So we've dealt with an awful lot of water that comes in because those valves aren't here. We have had some whopper floods and storms that would overwhelm if you just block off these drain systems. Katrina actually would have had 1.5 feet of water over the seawall. Isaac would have been close to that, and the storm that stuck in Texas, Ike, actually had about 6 feet of water at the Mandeville lakefront. So we would have had water crusting over the seawall, but it would have only been there for 3 hours. What happened in Ike, that's the time frame. What happened in Ike is the whole neighborhood filled up with water as the water kept flowing. If the neighborhood was dry, when the water crests over the seawall, there's someplace for it to go. It can flood Lakeshore Drive and it can fill up slowly, as opposed to the whole neighborhood already being filled. Then as the water rises, it comes onto the properties. There's just nowhere else for it to go. So to me, the Corps of Engineers and the Louisiana Department of Transportation had this correct to block the water at the lakefront and stop it from coming in the wrong direction. Just, it's not there. And because it's not there, that's why we deal with so much flooding. Mr. Ernest mentioned what this costs. The figure that the city gave us for the cleanup after Isaac was $600,000.
Wow.
They did $400,000 worth of damage to the fishing pier. Their total cost was
Something $1 million. Yeah.
2.4 million, something like that, counting security and all the stuff that taxpayers get to pay for an event that can happen
Every few months.
every few months. At least. I mean, Katrina and Rita both did this within 10 days of each other. I know I was leaving for Rita. Okay, I'm going to stay after the meeting. This is just, as I said, this is an illustration of one of the streets. All the streets are a little different because the contours are moving up and down, and water is always flowing. As it's rising, the object is to keep it contained as long as you can in the lake, and then once it comes over the seawall, then it will fill up. If you have an Isaac that lasts for 3 days, that's a different thing than a storm that passes relatively fast and you have flooding for 3 hours. So no solution solves every problem, at least no solution that anybody would be in favor of. But every storm's a little different, but what we have isn't working for any storm.
True.
Yes, ma'am?
You may not be able to answer, but Ernest may know the answer to it. How many outlets do we actually have in the seawall?
A little over 30. Well, I think there's supposed to be over 30, but what's happened is that when Mike looked at these drawings, he found that some of them were merged into one. And so instead of, each side of the street had its own drain. And so there may have been 30 or so drains across from the west side all the way to the to Bonnie Castine. But because some of them were consolidated, there may be only as few as 20.
We actually think 22.
22. Now, Coffee Street, we have our new fiasco, and it turns at Jefferson and dumps into the bayou there.
Correct.
So if you're going to do backflow preventers and all that wonderful stuff, if we go, we will not be left out of the mix, because I'm watching for water tonight.
We're going to discuss that
4
later.
blocks up.
We're going to discuss that later.
Okay, because that's part of the same scenario.
Remember, because water is always flowing downhill, these streets are all being the subject of what's uphill and draining down toward them.
Yeah.
So if you had a very slow moving storm and you had 5 feet of water in the lake for 3 days, this is still going to fill up with water from rain and from drainage from other areas.
Right.
This is not designed to solve that. The only way you could solve that is with pumping, and we're not talking about pumping. So this is designed to leave as much of our space available to contain water for as long as possible before it comes onto people's property. And the other thing about rainwater is you're dealing with much cleaner water than we are with lake water.
This is lake water at Jefferson.
Yeah.
It's lake water because it's in the bayou, a block from the lake.
Since I moved here, every pecan tree on my property has died. And my arborist says saltwater intrusion.
Saltwater intrusion, absolutely.
So if I just had fresh water, I'd be happier. And I also have a lot less marsh grass, and I have a lot less dead critters.
Yeah.
Okay? Now, let me go grab that other light.
Thank you.
Next is Glenn Mesman. His company HMI is down the street. He's got a PowerPoint demonstration to show you about the products that he sells and what they do. Can you all see this from the back?
Everybody okay with this?
Yeah.
Okay, I'm Glenn Mesman, and work with HMIM, and we are right down the street. We've been in business in Mandeville since 1987, and one of the products that we sell are backflow preventers. And I'll pass these two samples around while I'm doing the presentation. You guys feel free to look at it. I'm going to go through a series of slides here. Show you one solution or potential solution to some of the flooding problems you guys are having. And as Mike mentioned, a big problem that's occurring out here in the lakefront is just that. The water from the lake is coming through the pipes, the outfall lines, and filling up the drainage system. So when a rain event occurs, the drain water from your property has nowhere to go. What a lot of municipalities actually utilize this product for, it's called Tideflex, is to actually save that storage space of your pipe. In other words, if no water is coming in from the lake, when you have a big rain event, you actually have a place for your water to drain. Okay? It's not the solution to all of your problems by any means. It's one solution that I think will help. And as Mike mentioned about the piping, there's a lot of pipe that could be used as storage for your drain water that's just inundated with lake water. So this is just an informative presentation. I'm not an engineer, unlike Mike, so I'm just here to let you guys know what's available in the marketplace. So let me just begin this. To start this off, I want to just do a little exercise, and I call it, what is that noise? Okay? I just want you guys, all of y'all I assume live in the area, I want you to close your eyes for 30 seconds, if you don't mind. If you're scared of the dark and you don't close your eyes, I completely understand. And I want you to think in your mind, what is this noise? Where have I heard this before? And there is a guy laughing on the video, so it's don't give me the answer of, you know, that's Ren laughing. So let's do this real quick, if y'all don't mind. Just close your eyes. I'll replay this in a second. Here we go. Okay, you can open up your eyes. Let's play it again. I think most of you guys know what it is. It's not a toilet flushing by any means. This is a catch basin by the lake. What you hear is lake water coming into the catch basin. That's a nice wave. Okay, so you know what we're trying to do here is try to keep that lake water from entering your drainage system. So what you have is you have a pipe, like Mike was talking about, draining your subdivisions into the lake. You have catch basins along the way, down the streets. This one's out by the lakefront, by the flood wall. Here's a video of what's in the catch basin. This is on a very calm day. I think this was Tuesday. You look in the bottom of the catch basin, and you already have water. Again, this is supposed to be draining your properties. Okay? This is the discharge pipe coming from the catch basin into the lake. Calm day. It's almost all the way inundated with seawater.
Excuse me, how much is covered by like the silt right now? I mean, in front of my house, those pipes, most of them are the ones from my house, maybe 2 or 3.
Right.
They're covered with silt.
Right.
Full of silt?
You know, I'm not sure. I didn't expect every outlet. I looked at a few of them,
You
and
can
I'm
actually
sure.
walk by those drains, you can actually
Yeah.
hear water going back
Oh, yeah.
and forth, and those are the
Right.
ones that aren't covered. So,
Wow.
Yeah, I would imagine that, you know, if you're gonna put some outfalls on these outfall pipes, I mean, some backflow preventers on the outfall pipes, there will be a series of, you know, cleaning that would have to take place. The product that I'm passing around actually works in silted environments. So, okay, so this is a concrete pipe that's discharged. Again, calm day. You know, you already have a bunch of water coming up, right? Now, this is not a very good picture. I'll show the next one. This is just another discharge pipe. This is style 2. This is what Mike was talking about. If you look at this next picture, you're going to see around the perimeter of this actually bolts. And we believe, through discussions with various people, that the Corps was intending on installing some sort of backflow preventer on this outfall. And it never was installed. So, you know, 2 other pipes, again, you know, very calm, halfway full of water. Okay, well, today was a very windy day. We had I think it was an east wind gusting somewhere between 18 and 20 miles an hour, if I'm not mistaken. So this is on Carondelet and Lakeshore Drive. Pay attention to the water. This is on Lakeshore Drive. The lake is on the bottom. If you watch the water, it's coming in and out just like the lake moves. Okay, so catch basin, same day today when it's rough. It's almost to the top. That's only 18 miles an hour. Now this is the various catch basins around that same street, that same corner. And you can see every one of them. This one is hard to see here, but it's actually filled to the top. This one. This one I think is the same as this one, I can't remember. But, so all of these are already full. So
And that's
before,
about a half a block up the street, isn't it? The ones on the right-hand side?
these are all on the corner of Carondelet and Lakeshore. I didn't go anywhere but besides just right on that corner. So, you know, if these are overflowing, I'm sure a block down, you know, it's filling up. So, you know, this is a very pretty day, just a little bit of wind. So, what I'm here to talk about and to show you guys, and you know, I'm going to try to make it as easy as possible and just an informative presentation. Excuse me. Is Tideflex outfall check valves. Real easy. And if you guys have seen the sample pass around, it's a simple valve. It's made of rubber. Slides over the pipe, and I'll show you other options too. Forward motion opens the valve. Reverse pressure seals the valve. Real simple.
Is there enough fall to open that up?
These valves have the lowest head loss compared to any other backflow preventer on the market. Less than an inch of water will actually crack this valve and allow it to drain.
Okay.
And I'll go through some of that as we move along.
I'm sorry.
No, it's all right. Perfect flow. Very casual presentation. If you got a question, just let me know. Okay, so, you know, this isn't something that was just invented last year for you guys probably. This has been on board and manufactured since 1984. And actually, Red Valve or Tideflex actually work with the EPA. And the reason they work with the EPA is had issues with backflow coming from wastewater treatment plants. And the water was coming back into facilities that were having to retreat the water. Well, they had flap gates, which you may have seen flap gates before. They're metal flap gates. they have all sort of problems inherent with them. You know, they freeze open, they corrode. You know, you guys are dealing with salt water. This is rubber. So just to kind of go through some of this, just kind of give you a little history of the check valve that was installed in 1984 in New York City is still in service today. It'll be 30 years next year.
So they don't have alligators coming up in there.
Not yet. So this was, I think this particular slide was maybe 5-10 years ago. Over 600,000 of these valves have been sold around the world. That number's probably doubled since then.
How do you attach them? It looks like some of them you fit over a pipe and you tighten up.
Yep.
But the pictures you show that it's flat across, so how would you go about making the attachment?
Right. There's several different connection options. There's flange, there's slip-on, and there's another one we're going to show you in the slides here that is a thimble plate that actually go flat on the head wall with a stub end sticking out. You can slide this valve over. Each one of these valves is built to the OD of the pipe and built to your flow requirements. So it's not just something sitting up on a shelf. These are actually engineered for your application. Most of it's built on the backflow.
So what size pipes we have?
Well, anywhere between 15 and 36, I think 33 OD. These are built on the OD of the pipe or a flange, depending on what you have.
What's the price range?
Price range on the size that you guys have out there between $5,000 and $9,000.
A piece?
Piece.
Cheap fix, isn't it?
Excuse me, can I ask a question?
Yes.
Since the original pipes were designed to conform to a different kind of gate, how hard will it be to?
Well, you're dealing with a couple things here. That's been out there for 20 years. So whatever was out there, the flanges, if you look at the pictures, they were all corroded, probably going to have to be redone. You know, it's going to take a little bit more investigating as far as if the existing flanges would be utilized. This company can cut the flanges according to, they can build any type of flange you want. So if this particular flange is not just a Nancy 125, 150 flange, which is a set drilling, they could actually drill the pattern that you have.
So the cost would be the cost of the rubber attachment plus the cost of conforming it to the existing.
Yeah, I mean, that's going to drive up your price a little bit if it's not a standard valve, okay? Plus, you're going to have installation costs in addition to that. So what we figured, just throwing out a number, was right around $300,000 to do and that's with installation.
Give or take.
Yeah, and then you know, installation of the valves. Yes, ma'am.
When there's debris coming through the pipe, does that sometimes stick in the opening and cause it to malfunction?
It's a possibility.
Yeah.
It's all relative to size. And let me show you this slide. Okay. The problem on the left would represent a flat gate valve.
Yeah.
Okay. If you have a stick or something that gets lodged in a flat gate valve, the whole thing is leaking.
Right.
It's a disc coming on a piece of pipe. With the Tideflex valve, it's actually rubber. If you have something that's not the size of the valve, but like a comparatively speaking, you got a 30-inch valve, you got a 2x4 going through it, you get stuck. When you have back pressure in the application, since it's rubber, it tends to wrap around that particular unit. Okay, so you're not having the whole pipe that's open and leaking back.
So it's better, it's not ideal, but it's better.
Yeah, I mean,
It still works.
right. So, and they're also self-flushing. So when you have a big gush of water, they'll actually clean themselves out.
And Mr. Ernest, we would have employees that are trained to be able to check those. We
Volunteers
obviously-
like you.
Yeah. We'll take my little kayak out there, but I mean, they'll be trained, it'll be something we can clean out ourselves rather than have to
I'm
call
assuming so.
somebody.
This is just for information to show you what's available to solve the problem.
Right.
That's all.
Yeah.
So basically, this is just showing you, a traditional flat gate valve that happens to them over time. We did a project at Bayou Signet with the Corps of Engineers. We replaced a bunch of 48-inch flat gate valves. When we went out there, all the flap gates, the disc, were on the ground. So
Yeah.
that's what happens. They corrode. And you talk about ongoing maintenance, that's a problem. The other thing that this particular valve has, you know, this is through years of engineering, is a flat bottom, which enables you to install it lower. And I know these pipes are set at a certain height, but also they put a curved bill in there, and it gives the valve a little bit more of a natural closing ability and allows it to open and close easier as well. Yes, sir.
What other communities might have these and we can look at it?
Yeah, I have a couple slides for some projects that we did. We just finished a big project in Slidell, the Huntwig Drainage Project. We have, I think it's around 8 valves, anywhere between 24 and 72 inch in diameter.
Wow.
So, and what they're doing, it's very similar to what you guys have out here. And most of the projects that I work on, if they're not a pumping station, where they utilize these, it's for gravity drainage. And most of the applications here in Louisiana, we're draining into a canal, we're draining into a bayou from a subdivision. And again, just like this, instead of a lake, it's the bayou or the canal that comes up and takes all your storage facility out of it, and, you know, for your neighborhood. So what they're doing in Huntwig, and I'll show you a picture of that, is just that. There's a Camp Salmon, right? Salmon. And and then there's a neighborhood right on the other side of that, and there's a canal that runs in between. So they put the check valves on the neighborhood side, the backflow preventers on their pipe that drains the neighborhood. So when a canal rises, they're not inundating their drainage system with the water. They still have that storage facility, which is the pipes underneath the ground. That's what they're meant for, is to drain your neighborhoods. You know, this is just one little engineering thing. You know, this actually, through 30 years of development, they developed a spine here. Because this was the old style valve, which didn't have the flat bottom. If you imagine this, a 72 inch valve, it's going to flare way down here. So you had to have a lot of ground clearance. And then the weight of this thing, we had some projects where they may have cracked open a little bit. Well, that's why they put the curved bill on it. And then they put this increased stability utilizing the spine on the valve. So this has become our standard, you know, through 30 years of development. All right, so this is in Australia, and they had problems just like you guys had. And one of you guys mentioned silting. Well, they put these check valves on, and it really solved a lot of their problems. And what happens is with this particular valve, since it's flexible, it's rubber, and it's not a flat gate where it's locked in a position, you have a vertical opening. As if this thing is inundated with sand and submerged in sand, even a slight little bit of water coming out tends to erode that sand away. And I like to compare it to if you stick a hose in a mud pile. Remember growing up, you stick a hose in a mud pile and turn it on a little bit? Before you know it, you got a big hole in there. So it helps to erode the sand around from it. Again, another picture. That looks very similar to what you guys are dealing with. Okay, and this is I think a really nice picture because it tells a story. This valve is almost fully submerged in sand, but if you see around the exterior, the exit of the valve, it's draining water. It's a very telling photo, I believe. Here's one in New York. The valve was buried almost 3/4 of the way and it still operates, still drains. Yes, sir.
I'm assuming that this device is a gravity flow device as opposed to induced flow.
That's correct.
But I wonder, what is the head pressure? How much head pressure would it take to operate this device?
Around an inch of water.
An inch?
Inch of water. That's right.
Given what diameter of valve?
It's differential pressure. Okay, so it's a check valve. Most check valves work on head pressure and back pressure. Head pressure opens and cracks the valve, and back pressure seals it. So, you know, if you're talking about your application at the lake and you got 6 feet of water on it, you're probably not going to generate enough head with the slope you guys have in your pipe to open the valve. Okay, so that's...
Well, it would be mute at that point anyway.
There you go.
There
you go. The idea we're trying to present to you guys is, you know, before the storm comes, like today. Suppose those outfalls are blocked off and you had 12 inches of rain coming down. Where's the rain going to go? You know, so again, it's not going to solve all your problems. This is a neat photo because if you look here, that water is actually draining out of the valve. It's halfway submerged. So in this particular case, the head pressure of the water in the pipe was higher than the water in the lakeside. Okay, here's Huntwig. This is in Slidell. This is a very hard picture to, I mean, it's hard to see it, but that's the Tideflex valve. I'm on one side of the canal, I didn't have enough zoom on the lens. That's like a 42 inch, I believe. This is a 60 inch. And again, you have the neighborhood on this side. Here's the canal. And the canal rises, and they're preventing the neighborhood from flooding. With, you know, they're saving the storage space. Okay, what I wanted to show here was, this is that 60-inch valve. And if you notice, it's hard to see, but this is draining. So it's not holding back a ton of water and then opens up and releases the water. This valve is cracked open with there's probably an inch of water or two in the valve itself. Okay, so this, how do we install it? And this is what I was talking about earlier. So you have a slip-on design. It's based on the ODV pipe, and there's clamps that go around the valve and attach to the pipe itself. There's a flange unit where the flange is actually built into the valve itself. You can attach that directly onto the head wall. So like if you wanted to cut off the existing flanges and drill into the head wall, you could do that as well. And they could even oversize this flange here, maybe make it a big square to where you could, you know, compensate for the area that's maybe damaged from you know, that's been on there for 20 years and get into the meat of the flood wall itself. And there's another one called the thimble plate installation. And what that is basically right up against your head wall. The reason for this option is, if you look at the flange valve versus the slip-on valve, it's generally, the flange valve is more expensive. And some people, like, depending on the size of the valve and how many they have, they could potentially save money by utilizing this particular setup, a thimble plate, with a slip-on valve. Just an option. And I thought of you guys with the flood wall out there that, you know, if you cut some of those old nasty flanges off straight, and then you could have, you know, a new stub in coming out, and just slide your valve right over, and that's what it looks like.
I got a question.
Yes.
How many of the current drains that are out there are underwater?
Ren would probably know that.
Well, the reason I'm asking that is, how deep does the water have to be to where that flange will not open up?
Excuse me, I'm sorry?
How deep would the water have to be to where that flange would open anymore? What I'm getting at is, I see that works if it's above, but if it's already underwater,
right?
How is it going to open?
Well, you have to have the head pressure to open it.
Right. The water on the inside has to be higher than the water on the outside. As soon as there's an inch of difference between the water inside and the water outside, it will open and water will flow out.
Yeah. Now keep in mind, you have a slope. You're creating head pressure. It's not just, you know, water inside the pipe. You got a little slope here on your headed towards the lake. Would you say, Mike, 4 foot? 4 foot slope over 1,500
to 1,400 feet. Yeah.
So I mean, it's not great, but you have something.
You've got that prior slide that shows the valve half covered with water. It's still draining.
Correct.
Correct.
Sir?
Yes.
If these things really work as you say, that's impressive. But I must admit, if these things can be seen, don't you think, given the fact that the lakefront is so beautiful, that we should have something prettier?
Well, you guys can have a painting morning. I think.
You need to flood it.
That's
right.
If you install this on the bottom of a 32-inch pipe, the bottom of the pipe is here. Most of these, the water level is at least halfway. Some of them, it's all the way. This part here that sticks up is literally going to be under the seawall cap. So the only way you're going to see it is to stand there and look over. But from the seawall and the inside, you won't see it at all.
I'm very impressed with this thing. I'm optimistic about it. And you do put them on sewer lines too, because I understand we don't have them on our sewer lines either. And so I may be interested in talking with you on that.
Yeah, absolutely.
But my other main question for the group is here. We still have 2 bayous that are open.
We're getting to that.
Okay. I just move along faster. I'm sorry. I'll sit and have another glass of wine.
Yeah, so, you know, that's a good lead-in. So, you know, we talked originally about the bayous, Ernest and Rick and I, and you know, those bayous have been open for so long that I don't think anybody's going to allow, any agency's going to allow you guys to shut those off. So it's going to have to be something that you could open and close, in my opinion. So we originally talked about something like this, where you would build a concrete head wall across the whole bayou and have some valves. But, you know, that's probably not going to be allowed. But let me get to the slide that I want to show you. But this is in Buenos Aires, 13 96-inch valves for a flood project.
I don't think that's gonna go.
Why, wait, hold on, why wouldn't it be allowed? Who's gonna stop this?
Well, I think personally, just by being in this business for a while, that, you know, you have wildlife in there, you probably have fish and whatever else, who knows, you might find some crazy frog in there that, you know.
It's a man-made drainage canal.
Yeah. I'm not with any agency, I'm just giving you a heads up.
I know, but I have heard this for so many years, and every time I ask someone something, I get a different answer.
Right.
And no one brings the person here who tells us that we can't do it. And I've heard all kind of people.
NRCS,
don't tell me.
U.S. Wildlife Fisheries, and U.S. Corps.
Okay.
I'm just telling you.
But you're guessing. You're guessing.
I am guessing. You are correct.
We have a simple solution, so.
Yeah. So, you know, one way to solve that issue is you're going to have to hire an engineer to look at the flows. And what you could do is, you know, you could install what's called sluice gates.
Yeah.
And these are manually operated gates. So across that bayou, right, I was walking out there the other night with my wife, and you could actually install this header of gates right on the other side of the bridge. A guy from the parish, city, can come up there and open and close these gates when a storm comes. We did these for some core jobs, just for that reason, that they wouldn't allow us to keep the water stagnant, I guess is what you call, on one side of the gates. So when the storm would come, we invented these to where it's a sluice gate. Now you don't have to have this Tideflex valve on there. You can just have a solid gate. This particular gate for a core project had a Tideflex on it, so when the gates were closed, they would still allow water to go out. So, you know, if you look around the city of New Orleans, all the pumping stations in Jefferson Parish, a lot in New Orleans, I mean, we did a lot of that core work that have sluice gates. It's you know, the only issue that you got to think about when you have a sluice gate is if it's 5 feet tall and it's closed, why not? You can see through it. When it's 5 feet open, it's going to be 5 feet above the top of that. See how this opens here? You know, that gate's down, you can see through here.
On the Chapelite, don't they move them completely? They move them completely.
Yeah, that's a little different. That's like logs, I believe, that have.
Yeah, but I mean, we could do something like that, and then just a few of these that could be dropped
Yeah, I
in.
mean,
That's not possible.
I mean, I guess anything's possible. It's, you know, the engineer
Can work that out.
needs to probably work on that because they're going to look at the flow characteristics and you know more about that than I would.
Wait, let me go back to this again. Why is it you can't build a solid wall around the two drain? Wait,
Maybe you can.
Let me ask the question. Let me ask the question
Yes,
first.
sir.
You put a solid wall in there and put like 3 of those these little devices across there, which are going to do the same thing as the lake. And so, I mean, I presume that you could have fish that go up right now up all the drain we got now. So I'm not really concerned about a fish in a drainage canal.
Right.
And I don't think we're talking about any kind of swamp area. We just this was a natural drain that was in the 30s that was diverted and made a natural drainage area to a man-made drainage area in the 30s. So I mean, there's nothing. What's the drawback on doing that? Is there a drawback? Forget the core for a second. Is there a drawback for doing that?
I'm not sure of the drawbacks. I know that we have done this. There's a picture one right there. And what our engineers do with Tideflex is they take into account the size of the channel, the flow, and they stagger these valves. So you might have a big one on the bottom and a bunch of little ones. So as the water rises, each valve opens and meets that flow or that drainage that you require in order to drain that body of water. Look, I'd love to sell you a whole wall of these things. I don't have a problem with it at all. So the guy at Tideflex could actually help you guys and the city engineer to design something like this.
Mr. Ernest, could I ask you a question, because I done forgot that, and you said it. When they did this in '93, this was a core project? What did you say it was a core project?
Plans for a replacement of Mandeville seawall, St. County Parish, Louisiana, U.S. Army Corps of Engineers, New Orleans District.
Yes, New Orleans District, so we are in the New Orleans District.
At least back then you were. And the engineering was all done by Brown Cunningham Ganoush, a big engineering firm.
What's the chance of getting the Corps to pay for this?
You can stomp on them with both feet.
Well,
They're
you know,
good at
I
that.
think the problem with this stuff is that the solutions is that if you wait for someone else to take care of you, you're gonna wait for someone else to take care of you. If you decide you wanna take care of yourself, you are then in control at least somewhat of your own destiny. And I'd rather be controlling my own destiny. If I can do this for $300,000 and the city can afford to pay it, then I would rather do it. If I can do something else for $5 million or $10 million and the city can pay for it, the city can borrow the money, before I go to the Corps of Engineers or the state of Louisiana, I'd rather do it ourselves. We have control over our own destiny.
Well said.
You'll be
But we
saving a lot
can
of
still
time.
come back and kick butt on the Corps to get some money back.
Yes, ma'am.
What would be the additional cost of the sluice gates for the two bayous?
That I really couldn't even begin to guess.
He didn't
So
really
high? So high you can't guess?
No, I didn't ask him to price that out because that's an unusual solution. And it would have to be tailor-made for our needs, and there are a lot of different agencies. The city has no control over this by itself. The feds are gonna control it, the state's gonna control it, and we need to work with them. We bring a solution and they need to approve and let us do it.
My absolute wild guess would be $20,000 to $30,000 a piece, not $100,000 and not $50.
For each sluice gate?
Yeah, $20,000 to $30,000 should get something to block off those canals.
I'd almost say a little more.
But this is
I'd
just
say
information.
probably
Yeah,
50.
I think that.
This is just information so you can see what options are out there.
Right.
Because, you know, like, if you're like me, I didn't know what any options were out there. And we discovered this option, you go, my goodness, this is available, we can find out about it. We don't have to wait for someone from Seattle or New York to tell us what's gonna happen to us. We're looking at this ourselves and we're trying to see, can this work for us? And if it can, what is it gonna take to do it? And that's it. I mean, I wanna give you all options so you all can let us know and let the mayor know, this is what we want. And this is what we've seen can work and stuff, and just, we're all educated people here. You know, we have an affluent community, it's an educated community. You may not be engineers, but you can see how this thing works and you can see the advantage of doing something like this. Before today, I suspect that few of you knew this was even available. But now that you know what you asked for. Finish up.
Well, that's really, I just wanted to put this list up there. This is just a partial list. I mean, we've been promoting these things since '98. And so, I mean, this is most of our recent projects.
I have another question.
Yes, sir.
If you're an engineering firm, am I correct that if we just asked you to give us a price, you're gonna come back and give us a price, aren't you?
I'm not an engineer. Right, I'm a rep firm.
Okay,
Right.
but if I asked you to do this, aren't you just gonna come back and give us a price?
Yes.
I mean,
For the product.
this doesn't seem real complicated, you know.
Right.
I mean, you sell these things, you know how to install them, you have to go and look at it, and you're gonna give us a price.
Right.
And it doesn't require the mayor or anybody else, besides you two guys, to tell them to give us a price, does it? Am I right about that?
No, we had a contractor come out and basically just,
Yeah, you gotta do it.
you know, it's hard to get an exact cost, but we kind of said, all right, I told the guy, I said, just kind of give me a rough idea of your worst case scenario maybe, you know, taking into account the different ways to install these things. And then he came back with a number, and I put my number out there, and I bumped it up a little bit just to put some fat in it, and we came up with right over $300,000. So, you know, yeah, I mean, we don't do the installation. I'll be happy to be out there to assist.
Go ahead.
All I want to know is the tributaries that we got three of them coming in there, Little Castine, and one down in the middle of town, and the one down on the end. Will all three of those be closed off also this way?
No, you just doing the pipes, he ain't doing the ravine.
Because if you don't, you're gonna have backflow coming through that way.
Well, there's other solutions that would have to be considered for the ravines, and one of them is that sluice gate, the storm
Yes,
valve, one's
yes,
gonna be
because
blocked
rain
off.
too.
There's a lot of different ways to look at that.
Yeah.
But they have to be addressed.
Yeah, that's part of the big
Yeah, this is just one potential solution.
Mr. Quinlan?
Yeah, how much influence and what would be the mitigation for the past the end of Lake Shore where you've got on the other side of West Street and all that coming over, what would that, how much influence does water coming in around that end of the lakefront?
It's an excellent question.
Yeah.
And the reason Galveston flooded in Hurricane Ike was that exact same problem. After the 1900 hurricane, they built a seawall that was 15 feet tall that faced the lake. Faced the ocean. The water came around the back and flooded Galveston Island from the back island coming forward. If the storm lasts long enough, the water will go around the seawall and we'll end up with the exact same amount of water we would have ended up anyway. In the case of a slow-moving storm like Isaac that hung around for almost 60 hours, I would think that would happen. But Isaac would have crested the seawall anyway. Isaac was just a really weird storm.
Yeah.
Katrina, you were talking about Katrina being a weird storm. Isaac was a weird storm. Wasn't powerful, but it just stayed forever. And my clients had more water damage than you can imagine from the fact that we had east wind-driven rain for almost 36 hours, which is also unheard of in Louisiana. So it's not the solution to everything. And I thought about water going around on West Beach and coming up through the marinas, and yes, it will do that. And if the storm is slow-moving enough, the resultant will be the same. But based on the amount of money we spent cleaning up after Isaac, these look like reasonable solutions that might save an awful lot of money for the not-Isaac storms.
And speaking of money, I mean, the council's already budgeted $1 million for this in this last budget we put in there. So we were looking ahead to try to anticipate what we might need money for to do these kinds of issues. And there's not just one problem or one solution for this lakeshore things. There might be dozens of them because each little area is going to have its own little special needs, and you have to custom solve each one of those problems. If you have 100% of the problems, it just solves 10% or 20% or 40% of 100% of the problems. You've licked a big part of the problem, because right just with Isaac, we spent millions of dollars in cleanup, which doesn't include all what you all spend in the personal losses you all sustain with this water coming in. And so we're trying to address these little things. It's chipping it away until you can get it down to the point where you can solve most of the problems. When Katrina comes, just evacuate. Mr. Gonzato, who's first?
These valves are definitely would help us with the water building up in the ditches, the systems. My question would be, are we also looking out to say, what do we do about the water that comes over the wall? Because a lot of people don't flood. They can. Some people do. And like I said, this one's going to help some folks, but the other ones, once that water hits that wall, where I live, you got about 20 minutes.
That's in the later part of the presentation, which is coming.
Good.
Another question here?
Well, that gentleman helped me with one of them, but I do have another one. If you're gonna, to me, what's the event going on today is not a concern. It's when it comes over the wall is the concern.
That'll be later on.
And it may, but if you're gonna attempt to get federal funding to do anything, and if you don't have high-powered data studies, and if you're going with anecdotal observation, you're not going to get the funding.
That's why I propose to ignore the federal funding. I would ignore the federal funding because it's too much trouble to fool with.
Well, but would you ignore the federal funding to solve the real problem?
Well,
this is not the real problem.
What is the real problem?
When it gets to be +5, that's the real problem.
And I don't think there's anything on the horizon that would give you an encouragement that that solution's in the way.
I disagree with that.
Okay.
I do.
I mean, the solution to that, if you were here earlier, is to close up the Wrigley's. That's the solution. That's not gonna happen in your lifetime.
It happened in New Orleans.
It's not gonna happen in your
They
lifetime.
put sector gates, by the way, they put sector gates on the intercoastal waterway, the Homer Navigational Canal, the Morganza floodway,
They
and
did.
any other opportunity. They spent billions of dollars on those sector gates.
That's right, they did. But the Corps of Engineers had a
We pay
plan.
taxes as
The
well.
Corps of Engineers had a plan and had drawings to shut off the Wrigley's in 1973. Okay? It was all drawn up. And what stopped it was an environmental group called Save Our Wetlands, who won a court judgment against the Corps of Engineers and shut it down. And I'm just telling you, give me a history. We can
What
debate all
stopped
you.
it was we're not an economic engine. The North Shore is not an economic engine.
That's not the purpose of this meeting tonight. I'm just giving you options. Yes, Nancy?
Ernest, I'd like to say that today is a perfect illustration of what is the problem. Already these catch basins are full, the water's halfway up most of our streets. The bayou that floods me is just below the drain in my yard. I live 1,000 feet up, but I'm on the little Bayou Castaigne. Now, one thing Glenn has addressed several times is the storage. If we had these kinds of flanges, these kinds of backflow valves, we would have that storage available, because tomorrow and Saturday could be huge rain event here. It may not be, but if we ended up with 30 inches of rain or 15 inches of rain, our storage is already gone. And that means my yard has flooded. Been there, done that, experienced it many, many times. When you have a complete non-event, but a strong easterly wind, and the storage is gone, and then here comes the rain. So I would argue that today is a perfect illustration of what this solves.
Yeah, that's true.
Yes, I'm done. Any other questions?
Yeah.
Thank you, guys.
Would you start that video?
Yes, I sure will.
This is another video that some of you have seen. Another constituent in the area came across it on YouTube, of all places. And it's an English company. It's called Rapid Dam. And what they have at the University in Central England is that they have a big water tank that creates waves. And they have developed a device that helps to neutralize the energy of the waves. Watch this thing and see what it does. Listen to the narrator about what he says.
And this is for going over the seawall, you said?
on top of the seawall. The following video sequence shows the testing commissioned at HR Wallingford, which is globally recognized as one of the world's most advanced hydrological testing centers. HR Wallingford is also the British Standards Institution's preferred supplier of testing for PAS 1188-2 flood protection products. The series of rigorous tests included an extended static test over 24 hours, current tests at a flow of 1 meter a second, and wave tests at a depth of 790 millimeters and a wave height of 295 millimeters.
It's about 3 or 4 feet high.
Subsequently, these test conditions have been adopted by BSI as the conditions required for the British Standard PAS 1188-2. The system is modular, and as such,
Hold on, guys, we got a connection issue here.
shows the testing commissioned at HR Wallingford, which is globally recognized as one of the world's most advanced hydrological testing centers. HR Wallingford is also the British Standards Institution's preferred supplier of testing for PAS 1188-2.
I think this is only a minute long.
Yeah, it does.
Another one.
Flood protection products.
I've seen that one before.
I have to find it. Let me give you all. What that is a flexible material, and it's shaped like a sideways parachute. And what this company does is that they can roll out like 40, 50 yards in 30 minutes. It gets bolted down to a rigid thing like a seawall. And that's what attracted me, is that I've been talking to the company about this. By this design like that, when the waves hit the top, it bounces back and kills the next wave that comes in, so it reduces a lot of the energy. It's not going to stop the flooding, but it reduces the energy of that hits that thing. If this thing is 3 or 4 foot high, and if you bolt to the top of the seawall, that would catch a lot of the waves. And so I was thinking, well, the lake is in Katrina, it came over the seawall. This thing would, might slow some of that stuff down. I've been talking to the company. I sent them some of these drawings. And they said, it's possible. We'd have to look at it more. We just don't know. And they have to look at it more because it's obviously be a big project. But this thing is about 2 miles of lakefront. And if you had 2 miles of this stuff, it would take you maybe 6 or 8 hours to put it out. And so 48 hours before a storm comes, you get everybody out there. And like in Europe, there's a lot of occasional flooding from rivers and stuff that raise their banks. Everybody, the firemen, the policemen, all get out and they lend a hand and they erect these things up. And you see them all across Europe, different solutions. This is just one solution out of many that affects the area. But there's a town in Germany, I saw a picture of a 10-foot temporary wall and the water a foot below the top. And you're at the promenade area where you can walk, and there's this wall going up 10 feet, keeping the river in its banks to keep a town from flooding. They take it very seriously. They want to protect those things. Some of those towns are 1,000 years old. This was intriguing to me because it was so portable. It's something you could store and just roll out there in a matter of hours to put it in place. I'm not going to say it's going to solve the problem, but I think you need to start with a clean sheet of paper and look at what's out there, because this is out of the box thinking. This is something that no one's thought about before. And that's what you need here, because if there is no federal money for us, if there is no state money for us, this is an opportunity for us to see about solving this ourselves. Now the parish has got their own projects in place to try to mitigate flooding. This would be a direct impact on this community right here, right now. And that's why I thought you all would be interested in seeing it, to see how it works. Because in that demonstration, you can see what it does. And it might not work in our situation, it might work, but it's certainly worth a look.
Yeah, it's not the best connection here. We'll try again.
But I like the idea that it kills the wave action, because that's what caused the damage in ice.
Well, that's one of the problems. A lot of people on Lakeshore Drive is the energy that waves coming in just tears things up. At a prior meeting, I think Londi Moore, who I don't know if she's here today,
for PAS 1188
was trying to find solutions to kill the energy by putting little berms or little small levees on Lakeshore Drive, and now everybody thinks that's an attractive solution.
We just don't have a very good internet connection.
But this is something else. I mean, this would be up maybe 48 hours before a storm hits and stuff, and stay up 48 hours afterwards. It would catch a lot of the debris, if it would work. We don't know if it would work. But it's something that I've been looking around, Rick's been looking, we've all been trying to find ways to solve the problem, rather than just throw up our hands and say, let's wait till somebody comes and save us. I'd prefer to get it myself and try to do something.
And Russell, to get back to your comment, remember you said 20 minutes from when the water crests the seawall? That's because the drain systems are already full.
Already full, correct. I understand that.
So if you had both solutions in place, then you'd have the ability for water still to seep through and come over and rain and drain and still not get water on people's properties.
That's what I would refer to, Mike. Actually, it's a twofold problem. The drainage ditch is one, but of course, once it hits over that wall, whether your ditches are drained, it's too late. But if there was, you're right, by that time it's not. Hopefully that type, another solution. I mean, you got all kinds of solutions. A lot of them won't like it. You raise the wall, you build a levee. But this one is something that I thought, of course, appearance-wise, it's not there until you need it. And then when you put it up and you need it, no one's going to be sorry it's up there. But I just don't know how good it would work. That's the thing you'll have to check out.
Correct. That illustration was with about 32 inches of water on the wavy side and relatively dry ground on the other side.
The only thing they were concerned about was whether the wind would have an adverse effect on it. But we just had a beginning conversation with these people and stuff, and it, you know, if anybody wanted to investigate it further and stuff, I'm sure we could figure out a way to either make it work or see what it would take, what solution would be there.
Did anyone ever have how high the water was actually over the seawall?
Yes, we have some data on that.
About how high was it?
In the range of 2
The
feet.
water when it comes to the seawall.
In the range of 2 feet.
Well, what we've had.
In the range of 2 feet, Ross.
For what? The train?
But then you've got 3 or 4 feet. That's what
All right, so you could also do something really crazy, like have those people come over here and install 50 feet and wait and see how it works, and so some water too. I mean, nothing stops us from doing that. Most experience I've had, they want to sell things and they'll come over here and bring you some samples. I mean, you don't have to go to England and figure this out.
I would invite them over and say, let's make this a priority. You can sell to the rest of the country who works here. You know, I mean, it's all kinds of ways. If you're motivated and you're open to these things, I'd invite them over and say, you know, what do you think we can do here?
It seems to me the backflow preventers, like, you know, what do you need to take it to the next level? Are you going to go to the council and say,
Well, the council already appropriated the money to come out of the city, you know.
Get an estimate?
They've got a study going on to study this very thing that we've been studying as well. And those people may recommend something like this, I don't know.
So we're waiting for a study now?
Well, you can, yeah. I mean,
We are waiting for a study?
it's going to be, I think the contract's going to be signed shortly, and I think the city's going to have another, next week, there's going to be another talk on flooding, and the engineers that are coming on board on Monday night to Fitzpatrick. And so, across from City Hall.
Across from City Hall.
Fitzpatrick Center. There'll be another public meeting on Monday evening.
And the topic is flooding.
I believe it's going to be flooding, and this company, GEC, that's going to be doing the study for the next 2 years.
This coming Monday?
2 years study?
Monday the 30th, 2 years.
So we're stuck.
They're gonna study it for 2 more years.
Can I say something? Number one, thank you all for being here. We kind of expected a good crowd. We didn't expect standing room only, but thank you all. This is the number one priority that we're dealing with. That's why we started this conversation. And we all understand that, or you wouldn't be here tonight and we wouldn't be so passionate about it. The only thing we really wanted to do tonight was start addressing possible solutions. We know that the problem is getting water out and minimizing the water coming in. Okay, that's our problem. That's our problem that we're trying to address. Anything is better than nothing, and right now we have nothing. The goal, as far as we're concerned, and what Ernest and I have been talking about for the last several months and with several of y'all, is to have something in place for this city by next hurricane season. Okay? Now, would it have been great to have something in place years and years ago? Yes. We're trying to address this, and we want to address it as fast as we can, but it's going to take a lot of thought. What we've tried to do this evening is look at a couple of possibles. You know, the flapper valves help with the water getting out, and the storm wall or anything else that we can look at helps with the water that's coming in. That's not everything. So what we want is we want your feedback. We're going to continue to work together, council, administration, anybody that we can talk to, work with, and look at are there other things that are reasonable, both in cost, aesthetics, and what we want to do for this area that is going to help never prevent, but certainly minimize and protect. And that's the goal of this situation and what we're trying to deal with tonight. So it's a start, but it's certainly, we're nowhere close to where we need to be at this time. But as Ernest mentioned, we've already tried to lean forward a little bit with budgeting some money now, so we're not waiting until next year at budget time and say, oh, now we need to do something. We're trying to put money in now so we have solutions in place by next spring. That's the goal.
Another question. Why is it you cannot go and put one of these on get one of these on installed now for the $600, $6,000, which is minimal, install it. If we're going to have a storm coming up, we can see how the thing works there. There's nothing but a couple of holes drilled in the wall, and they ask these people to come over here and put 50 foot in there. I mean, instead of just keep dragging this out for years, let's get something done, started.
Well, go ahead, Ernest.
I don't know who has authority over the seawall, whether it's the state or the Corps of Engineers, or the city has absolute control. The city controls it itself, and it's the city's decision what to do and when to do it. If the state has to be involved, or the Corps of Engineers, they will need to get permission from doing that, and that's the only thing.
Ernest, I think you have your solution already in hand. It has been my experience that the Corps of Engineers, who are the slowest dragging feet there is on the face of the earth, and it's not always the best solutions that they come up with. That said, if you have in your possession a 1993 end result study and project of putting those in with backflow preventers, you have the power play in your pocket already. I have, like I said, my
You must be reading
experience
my
has
mind,
been,
Atlanta.
well, my experience has been, once you pay for one of these outlandish studies, somebody else has to triple their engineering cost to fight one of those already tripled over cost, engineering studies by the Corps. So you're talking, 5 times as much to fight it legally. They don't have a leg to stand on. So you're holding the Bible in your hand already.
That's what I thought.
Okay, that's my experience.
One thing we haven't talked about is the jetties. And I'm gonna refer to history because Bill's dad grew up in Mandeville, and he had an engineering background. He died at 90 in 2000. He said when they built the jetties, they never did it right. They weren't supposed to go straight out. They were supposed to be at least 15 degrees to slanted so that they would silt in and keep the beach. But since the engineers had it wrong, it eroded the beach. He said that the beach used to go out at least a block beyond where the seawall is now. I don't know if anybody else remembers. I don't know.
Yeah.
You do? Okay.
I played
But
on it.
anyway, how expensive would it be? And would anybody be interested in having those jetties positioned correctly so that it would silt in some and keep more water from, it would be shallower water anyway if it did come.
If GEC, the engineering firm's going to study is there next Monday night, you can ask them that question, because all we did was looking at trying to find ways to keep water from coming out of the drains. And so this is it. But GEC would be the one to address it, because they're, I think, doing a soup to nuts study of everything.
Thank you.
Mr. Clark.
One thing y'all could do that won't cost a thing is legislative, and that is to stop the change to the native terrain in this part of town that we all deal with. The importation of half of Mississippi to build platforms for new houses needs to stop. And it would help a lot with overland flow, it would help a lot with sedimentation, it would help a lot with trees. There's a million things that would help, and it'll cost you exactly nothing except to move to force changes to Cluro that reinvigorate a fill and excavation ordinance that we used to have.
I agree
That's
with
something
that.
y'all could work on.
It's my personal belief that all houses in Old Mandeville ought to be built on piers anyway. You shouldn't have on slabs here.
Yeah, and
It's
the
not a good solution for
pervious,
South
pervious,
Louisiana.
impervious areas that we have in Cluro now need to be reworked. That's another zero cost initiative by you all.
Glenn is more technically savvy than I gave him credit for. He doesn't work an iPod.
Oh, wow, look at you.
You're not supposed to be watching when he does this.
Well, if I could, I don't know, I wouldn't kind of jump the gun on that
All right.
technologically advanced.
Anybody else have any
Do I need
questions?
to get my 17-year-old grandson in here?
Ernest, let me mention real quick, this is obviously not only our problem, but everybody's problem throughout this area. The parish president just returned from Washington, D.C. yesterday. She met with Congressman Scalise and both of our state senators, dealing with the Wrigley's and other major flood protection control issues and possible solutions. That is just such a much longer term project, and the expense that goes with it. Our fear and our rationale for trying to do this is we can't wait for that. Will something happen at some point? And I think we all hope so, but it's not going to happen tomorrow. And if we, as Ernest said, if we can control this a little bit while we're waiting on the rest of the process, we might be able to get some stuff done, and it's only going to help us. Yes, sir.
Well, it's interesting that LaPlace and Reserve have $1 billion flood wall going up in no time at all, huh?
Crazy how that works, huh?
Yeah, isn't it?
Yep. So,
Because there's 2 oil plants there that almost got flooded in Knoxville.
Understood. But things can move when you have the right, when you have the right.
there is a lot of push from leadership throughout St. Tammany Parish and all of the Florida parishes to the Capitol, to our congressional delegation, and we're going to continue to push every municipality that is affected by water whatsoever, and the parish is pushing that very hard. So it's just time. But you're right. I mean, it's amazing how quickly things can happen. We just need some help.
Anybody else have any questions or comments? Oh, somebody in the back there.
Just final comment, thanks for doing it.
Oh.
Take little breaks now, baby stuff
Good show, people.
Thank y'all very much, have a great weekend.